in this video we'll be going over some complex motion pretty much. In this video we'll be going over a question that combines inclined planes and projectile motions. If you haven't seen the helicopter video, it was a pretty easy video on a projectile motion. This combines a couple ideas together, so if you understand it, that's okay, but if you are like almost there with your understanding and you want to challenge yourself, this is a really good question because it tests your understanding of inclined planes and projectile motions, as well as your pretty much your algebra as well. This question was taken from the Oxford Study Buddy for the Queensland Australian Curriculum for Physics, Units 3 and 4, Volume 1. So if you want to actually do this question, I recommend buying the book. It's a great book for physics students that want to increase their grades. Alright, so let's take a look at the question that we have here. So the question is basically a block is sliding down a plane, as you can see here, and it's going off basically a cliff and it's traveling a distance. That's basically the entire thing. So a frictionless plane of 1.2 meters long is set up on a bench at an angle of 25 degrees as shown in the diagram. A block of wood is allowed to slide freely down the incline and falls to the floor 0.8 meters below. So there's three questions. You got to determine the total time taken by the block from the moment is released until it hits the floor. You need to determine the impact velocity of the block and the distance it travels from the bench. So let's just start with taking a look at what we've been given. Let's just take a look at the incline. So we need to find basically the time it takes from the block gets to basically from here to here, and the time it takes from the block to go from basically there to there. So there's going to be, so for our total time, so T total is going to be equal to time down the incline plus the time down the bench. When I say down the bench, I mean it from going from here to there, the time it takes to fall from that height. Okay, so let's try and find the time down the incline. So we're going to need our equations of motion. So these are the equations of motion. So you have V equals U plus AT, S equals UT plus a half AT squared, and V squared equals U squared plus 2AS. So if you're not familiar, V is the final velocity, U is the initial velocity. So initial velocity is basically its starting velocity when T equals 0. T equals time. A is acceleration, and S is distance. Alright, so let's take a look at our incline. I'm just going to draw it here. So we've been given a distance, which is 1.2 meters. We've also been given, we've been told it gets allowed to slide freely, so it's basically been dropped on the incline. So we know its initial velocity is 0 meters per second. I'm just going to leave this spot empty here so I can work out what sign I have to have. But since the initial velocity is 0, this needs to be a negative sign. Alright, we want to find our T, our acceleration. That is a tricky one, but I'm going to show you how easy it is to find. So if a student saw this, they'd be like, oh no, how are we supposed to find our acceleration if you didn't know your inclined planes? So I'm just going to draw an inclined plane here. So we have on an inclined plane, we have a force of gravity acting straight down, so F of G, and we have an angle here, and of course we have its vector components with the angle here, so that's our normal force. There's no friction, so we're not going to have to worry about this vector here at all. We will have to worry about F of X here, so F of X is F of G sine of theta. Now, you're probably wondering how are we supposed to find our so F equals ma, and you probably with inclined planes you go acceleration is the sum of the forces down the slope divided by the mass. And you're probably wondering how are we supposed to find acceleration if we haven't been given a mass in the question? Well, we don't actually need the mass, which is it's kind of funny, isn't it? But I'll show you what I mean. So acceleration, let's not worry about acceleration for now. We know that F equals ma. We also know that Fg is mass times the gravitational constant, which is negative 9.8 meters per second per second. So I'm just going to put that over there. So we know that the force down the slope is Fg sine of our angle is 25 degrees. We know F here is that, and we know that is that. So MA equals mg sine 25 degrees. Can you already see it? We can cancel our masses. So our acceleration down the slope is the gravitational constant, g, little g, sine 25 degrees. That's all it is. So you don't need the mass at all, because it cancels out. So if you understood that, that's good. If you didn't, I can make a better in-depth video if you want. If you just leave something in the comments if you didn't understand that bit. So this is our acceleration. So I'm just going to get rid of this now. So we now know our acceleration down the slope. So we have 3 of our things. That means we can work out our time. Alright, so we're going to use this equation. S equals ut plus a half t squared. Alright. So S is negative 1.2 meters. U is 0, so that's 0 plus a half of negative 9.8 sine of 25 degrees t squared. Right? So I'm just going to rearrange this. So we have t squared equals 1.0 divided by 9.8 sine of 25 degrees, and there's a half there. I just cancelled my negatives. We're going to square root that whole thing and get rid of that. And then you're going to put that into your calculator and you should get approximately 0.76 seconds. So this isn't the total time. We haven't finished our question. This is the time it takes for the block to go from here down the very slope before it falls off. Okay. If you want to copy down any of those notes, feel free, because I'm about to rub it out. So now we found that, now this gets a bit more complicated, because now we need to find the time it takes for the block once it slides off the incline to hit the floor. So I'm going to take that information here and I'm going to move that up here, and I'm going to replace it within here. So this is our, whoopsie daisy. Sorry, I was being a bit fancy. I'll rub that out now. Alright, so our block, I'm just going to redraw this diagram here. Our block is here. This is like the very edge of the incline. And it's about to fall off this height. Now, it's accelerated down the slope, so its initial velocity, it's going to have a velocity basically going down like this. It won't be going up because it's sliding down the slope. So this is a bit different from normal projectile questions, because normally with other projectile questions you get given a block or something and it goes up like that. But this one, it's got a downward thingy, so it's going to hit the ground faster than previous projectiles that we've dealt with. Whoops. My rubber is not working. There we go. Right? So, velocity, we basically know what it's going to pretty much look like. It's pretty much its vector. So it's going to have a vector going down like this, and it's going to have an angle in here of 25 degrees, because this angle here on the incline is 25 degrees, that's 90, and that's going to be like, that's 65 probably. Yep, that's 65, so that must be 25 degrees there. Alright, so that's where we get our angle for our vector component. We need to find the final velocity down the bench, so we need to find our v here. Or, well, our v, our final velocity down the incline is going to be our initial velocity of our projectile, so I'm just going to put it as u. there. Alright? Okay, so actually no, I'm just going to put it as v so you don't get confused. So our final velocity down our incline. Probably shouldn't have got rid of the other information. So our t is 0.76 seconds. Our acceleration is, what did I write it down? Is 9.8 negative sine of 25 degrees. S is negative 0.0 meters. And our initial velocity is 0 meters per second. So this is just the motion down the slope now. So I've just gone back a bit because I forgot we need to find the actual velocity, our final velocity down here, because we're going to need that for our next part of the question to find the time it falls. So we know this equation, we're going to use this equation here, v squared equals u squared plus 2as, right? So we want to find v, so v is the square root of 0 squared plus 2 times negative 9.8 sine of 25 degrees times by negative 1.2. This is all square rooted. Putting that into our calculator, it's 3.5 meters per second. So that number here is the velocity of the block as it falls off the slope. Okay? We don't need any of this information anymore. Right, so that's the only bit of information we need is this number here, 3.15 meters per second, because that's going to be our initial velocity for our projectile here. So I'm just going to redraw the diagram I had before. It's 25 degrees. So its velocity is, its initial velocity off here is 3.15 meters per second. And it's going to have 25 degrees here. That vector component, that vector component. Alright, cool. So to find our time of basically descent, it falling 0.8 meters off the bench, to find the time it takes to go down the bench, we need our vertical motion. Because our horizontal motion doesn't really affect the time of flight that much. More so, the time of flight affects the horizontal motion, and the vertical motion affects the time of flight, so yeah. Alright, our vertical motion, our acceleration is negative 9.8 meters per second. We're going to need our initial velocity in the y direction. So it's going to be, since it's going down, it's going to be negative 3.15 sine of 25 degrees. So just putting that in our calculator, that's approximately negative 1.33 meters per second. Not meters per second, meters per second, because that's velocity, not acceleration. Alright, I'm just going to move this information across here. Alright, so now we are going to, what else? Oh yeah, so u of y, u of y equals negative 1.3 meters per second. We're looking for our t, and we have s of y, which is our distance here, which is 0.8 meters. Now, normally if you have this equation here, and our u is 0, s must be a negative value. But since our u, and if we had a u with any other value here, s would have to be positive. But since our u is negative, our s has to be negative as well. So these are the three cases with this equation. This is very important information. I would copy this down to help you solve any problem, and it'll stop you from getting stuff wrong. It took me a while to actually work this out, but it comes back to the discriminant of a quadratic pretty much. This is such helpful information. So if you have when your initial velocity is 0, your s must be negative value. If your initial velocity is positive, your s must be positive. But if your initial velocity is negative, and hence it's going down, your s must be negative. So that's just some important information. Alright, using that information, we're just going to plug it into our equation here. So we're going to go negative 0.8 is equal to negative 1.33t plus a half of negative 9.8 t squared. Now, you could use the quadratic formula, but in physics you don't need to show maths to get the marks. So you could use your graphics calculator and go solve n, which is a function of the graphics calculator, and it will solve this equation for you. And when you do that, you get t is approximately 0.29 seconds. Okay. So now we've got that. That's the time it takes from the block to fall from here down here. Sorry, this diagram is a bit cluttered. So that's the time it takes from this block to go. Alright, so now we can work out our total time. So I'm just going to rub out this information now. This is a huge question. If you think you've got a pretty good understanding of motion, I would definitely give this question a go without watching any videos on it first to really test your understanding. Because this is A grade, I definitely think. The maths isn't too hard, but the understanding is A grade. So T of total is 0.76 plus 0.29. So our total time is 1.0 seconds. Now, if we put that in here, you would get 1 out of 2 because we need to express our answer in one decimal place. So 1.1 seconds is the correct answer. 1.1 seconds. Right, that was part A of this question. So I have no idea why this was 2 marks, because this section down here is a lot smaller than that section. I think they should switch these marks around, personally, but that's just my opinion. Yeah. Alright, let's go on to part C of our question. So, no, not part C, part B. So part B is the impact velocity. So what does impact velocity mean? So this block is going to go like here. So you want to, what we're basically trying to ask is, what's the final velocity? Pretty much. So it just comes back to this vector we had before. Well, basically our final velocity is going to have a Vx component and a Vy component. And its final velocity is going to be here. So you need to find this and angle it hits at the horizontal. So in the x direction, which is the horizontal direction, since there's no acceleration and since we're like ignoring air resistance and stuff, u of x is equal to v of x. However, in the y direction, the vertical direction, since there's gravity, we can't say they're equivalent. So only in the x direction. So using our thingy we had before, I rubbed it out before. What was it? It was this thingy. It was this triangle here. It was 25 degrees and it was 3.15. So our u here is going to be 3.15 cos of 25 degrees. Using that calculator, that's 2.855 meters per second. So that's just from the previous question bit that I rubbed out. You can rewind to get the actual thingy. Alright, so our ux here is going to be 2.855 meters per second. So now we need to find our v of y. And to find our v of y, we're going to need an equation of motion. So our initial vertical velocity that we calculated before, so u of y was negative 1.33 meters per second. So now we need to find v of y because we have acceleration. We've also have its distance, which is negative 0.8 meters, and we also have acceleration, which is negative 9.8 meters per second. So we can use this equation here again. So v squared of y equals u squared of y plus 2asy. So v of y is the square root of negative 1.33 all squared plus 2 times negative 9.8 times by negative 0.8. Oh, I'm running out of room, so I need to move this across. Yep, pretty much. And putting that into our calculator, our final velocity in the y direction is 5.059 meters per second. So just putting that there, meters per second. Alright, cool. Now I'm just going to rub this all out. We have that now. Now we just got to use Pythagorean's theorem. We know that a squared plus b squared equals c squared from basic year 9 math. So therefore our v here is going to be equal to v equals excuse me, square root of 5.059. Oh, whoops. Sorry. That's incorrect. Whoops. Sorry, I wrote down my answer thingy wrong. That's actually, when you put in the calculator, is 4.177 meters per second. What I was writing before was actually the answer, because I solved this problem beforehand, so I could explain it to you guys easily. So v is the square root of 4.177 squared plus 2.855 all squared. And then v is our number we had before that I sneakily put in there. And then you'd find the angle here. So angle here is opposite adjacent. So tan theta equals opposite over adjacent. So tan theta is 4.177 over 2.855. Theta is tan inverse of this. And theta is approximately, worked out in the calculator. So we'll have tan inverse of 4.177 over 2.855, and you'll get 55 degrees 0.64. Alright, so final velocity needs to be in 1 decimal, so it's 5.1 meters per second. So you go 5.1 meters per second, 55.7 degrees below horizontal. And boom, you'll get those marks. Alright, part C apparently is worth 4 marks. But that's rubbish, because it's not. It's basically just one simple calculation. Well, it's not simple. You basically got to know what time you have to use. Basically, part C is just working out its distance here, which is going to be s of x is u of x times t. Now the t you have to use is the time it took to fall from here. You don't use the total time, you use this time here. So s of x is our initial velocity in the x direction, which is 2.855 times 0.29 seconds. So s of x is approximately 0.829 meters. And you put it to 2 decimal places, so 0.83 meters. Apparently that's 4 marks, which is rubbish. All the working out came from part A. So I think this marking here should be switched. Anyway, that was a hard motion problem. It took me about not half an hour on my own, probably about 10 minutes on my own to finish it. But I'm pretty good at physics, so for the average person, they would probably not solve this or take a lot longer. So if you got that straight away, good job. That's a really hard question. If you want to cover any more complicated motion questions like this that involve inclined planes and projectiles, please leave some in the comments and then I'll try and get back to you. Alright, thank you so much for watching. I hope you learned something.